points that come with our book. So when we look at water, water is probably one of our major limiting resources on the earth, and this is not only true for us, but basically every organism on the earth. And most creatures, at least the terrestrial creatures, require fresh water, and particularly us. We are users of fresh water not only for drinking, but for running many of our operations and doing agriculture. And as we can see, when we look at freshwater reserves, fresh water actually makes a very small amount of what we find on Earth. So this large sliver here is what we call salt water. We've discussed ocean ecosystems already. So salt water makes up about almost 99, 98% of the water available to us. And this is a big issue when we look at usability of water, because most of the water available to us is in the oceans. And unfortunately, much of the ocean water where we get a lot of our resources like algae, you'd be surprised how much algae we use in everyday products, fish, and other sea life. A lot of that water is polluted and affects their populations and access to that resource. So just a very small sliver of water is fresh water. And most of that fresh water, at least for now, until more glaciers start melting, ice water and glaciers make up about 75% of that tiny little sliver. And some people estimate up to 80. It really varies. And then we have this stuff called groundwater. This means that is water that is trapped in soil or underneath, and we have to really work at getting, if we can get access to it at all. Because some water is actually what we call hygroscopically bonded to soil, and we can't get out. And then when we start looking at rivers and lakes and other freshwater bodies, this is a tiny sliver of what's available on the earth. That means it's 1% of this tiny sliver, and this is the water that we really rely on for our survival. And then we find water, again, like I mentioned before, bound up in soil, and this is water we have no access to. It's mostly involved in the composition of soil. Now, water is part of what we call a hydrologic cycle. And what the hydrologic cycle is, it just means how does water circulate through the environment? And particularly going from fresh water to ocean water, we see this cycling. So when we start looking at the water cycle, what we need to pay attention to is the ultimate source of water, at least for our Earth, is some form of precipitation. And that just means water in the form of either rain, snow, in some cases ice, and in some cases cloud formation comes to the earth, because clouds do drip water onto the earth by passing through mountain ranges and passing through trees. And in some areas, like particularly Central America and some of the mountains of Asia, the only water they have available is through literally clouds that condense on cooler landscapes at high altitude, and also on tall trees, and particularly in mountainous areas. So, and when we start looking at precipitation, again, this it doesn't matter if it comes in the form of ice, snow, or rain. It's still very critical. Usually when it's in the form of ice or snow, that becomes somewhat of a reserve. Rain tends to come all at once, as we learned, living in Houston. So what happens to precipitation is usually it ends up either in what's called surface water. That means a body of water like a lake or a river. Okay, and those are usually freshwater supplies, or it can end up in groundwater. That means water that either goes into an underground reservoir, like what we call an aquifer, which is a porous rock that basically passes and stores water for sometimes up to tens to hundreds of millions of years. Like we live off of what's called the Gulf aquifer, which has water that's almost 1 million years old on average. And water could also end up in oceans, either directly or through fresh bodies of water. What happens with the water cycle is once water is a liquid, either in salt water form or fresh water form, or in soil water, that water tends to evaporate, or to be passed, or be what's called transpired through trees. It means trees constantly taking water from their roots and pass it into the atmosphere. That water then goes as vapor, which then becomes clouds and water droplets, because clouds are actually water droplets that contain dust and other particles, including bacteria, funny enough, help with that. And this cycle starts all over again. So this is called the water cycle. And anything we do to affect the water cycle is significant. For example, we could build dams that block up a river, okay, or in this case, an estuary, and can prevent fresh water, what we call recharge, into the ocean. And this can actually affect the oceans greatly, because this here, where fresh water meets salt water, is an important ecosystem. Plus, it replaces evaporation of water from the ocean, because rainfall doesn't always have the potential of replacing ocean evaporation. We could also pollute water, which then makes it unusable for us and wildlife, and has to be cleaned. And that polluted water could also get into groundwater, which travels for sometimes hundreds of thousands of miles to other places, just like river water too. We could end up disrupting temperature, like global climate change, and that could affect the form of precipitation or where precipitation occurs and how much. So all of these are very important factors when we look at water. Water is probably our most fragile resource, and the United Nations recognizes it as not only a human right, but also a global security issue. We actually deal with water and call it water security, meaning that the world should have access to abundant, that means not water to waste, but water for your survival, abundant water, and also water that is safe to drink and clean of contaminants, and actually tastes somewhat okay. We call that potable. It doesn't mean it tastes great or is clear, but it allows us to live without illness. When we look at groundwater in particular, okay, and these things called aquifers, which basically means rock that was buried hundreds of millions of years ago and trapped water in it, and has a slow supply of water called a recharge area that goes through it. So much of our water, particularly in this area, we use groundwater. Some of our areas use what's called surface water, which again means water from lakes and whatever. But there are different types of groundwater. We have shallow groundwater, okay, which basically resides right around here in soil or in what are called superficial aquifers. And these are ones we do find in many areas where you just basically drill a hole in the ground and you have water. This type of water is somewhat clean, but also can be readily contaminated by something that affects the soil. Then we have more shallow, or what are called semi-confined and fully confined aquifers. Semi-confined just means an aquifer that is open to exposure from soil, okay, particularly in a recharge area, but is pretty much filtered by rock. Confined aquifers are sort of like, think about like a sponge. It's just encased in cement. And there's some openings in that cement that allow water in slowly to fill up that sponge. These aquifers are what we rely on a lot in many countries, particularly the United States. We have several major aquifers that span many states. We are along the Gulf Aquifer. Texas is also served by many aquifers, including a big one called the Ogallala and another called the Edwards Aquifer. This is usually millions of year old water and has minerals in it, but is very clean and usually requires no purification unless some accidental or intentional contaminant got in there. Sometimes there are natural holes in these aquifers which produce artesian wells or sometimes springs, like you find particularly around here sometimes, and also where Texas State University is. They have a beautiful aquifer spring, and you find some of these around Austin too. Some free flowing slow artesian wells with this nice, cool, clean water coming out into the Guadalupe and other main rivers. Again, we rely on aquifer water heavily in this area, and we're at the point that we're using it faster than what's called a recharge. That means rain in the area or other areas where this aquifer is found fills it up. So we could easily drain this thing and cause this thing to sink and collapse, which is actually what's happening here. We have areas of Houston that have now sunk about 50 feet slowly over time. We call this subsidence, and the land actually gets lower than the Gulf of Mexico after a while, which of course can induce flooding. And it also produces these basins that when we do have rains like we've had in the past and recently, that these can cause a flooding that does not drain. So aquifers are very critical to us. And unfortunately in the past, we've used aquifers of what are called injection wells. I mean, sometimes places where we dump certain types of contaminants to get rid of them and basically spread them out through the aquifer. So what are our influences on the hydrologic cycle, and how does that impact us, particularly in water usage and the pollution resulting from that. You're going to see that in another short video that's going to give a little more detail to this. But anyway, a lot of what we do is we dam water, we redirect it, we pollute it, and this all has major factors on the hydrologic cycle. So one thing we do as humans is we shift the hydrologic cycle to the point where it affects particularly rainfall and snowfall patterns, and also the amount of rain that could end up in an area. We also pollute the water. And guys, when water evaporates from the ocean or from lakes or soil, a lot of times it forms what's called an azeotrope. I'm not going to ask you that term. It's a chemistry term. But an azeotrope means that water sometimes can't be separated from a pollutant as it evaporates, and it can carry the pollutant with it, sometimes for hundreds of miles and sometimes across the earth. And we find that sometimes rainfall that occurs in Alaska contains pollutant contaminants that might have come out of Houston. And guys, another way we affect the hydrologic cycle is when water does hit the atmosphere, anything that pollutes the air, which we'll cover a little later, could also pollute water. So water is very easily contaminated, and the water cycle is very easily adjusted by us. Now, when we look at water in the United States, and this is not true for all countries, but particularly even other developed countries, is when we look at our fresh water, guys, fresh water, especially clean fresh water, that means even beyond potable. Potable means barely tolerable. We use very clean water in our country. Look what we use it for. We use it for flushing toilets for the most part, almost 30% of our water. Guys, most countries don't use flush toilets. I can show you pictures of toilets I've used across the world, and many of them you're just pooing or peeing in a hole, or you have a little a scoop that you just pour a little water into to flush the toilet, just barely enough to get it done. In other areas, you don't flush your urine all the time. You flush your chunks, of course, but then again, you do that on top of urine. So, we are incredibly wasteful, and most of the activities of our sewage treatment plants, which you'll see a video on that, deal with that, and it creates a big demand on water. We also look at lawns. And this is going down a little, luckily, due to the high cost of water lately and the difficulty in getting clean water, but still another third just for landscaping. And there are things we can do that greatly reduce that, even to the point of telling, community associations, hey man, there are other options besides having this very expensive and very water intensive lawn. Bathing, I hate to think what we do if we stop that, but we tend to bathe much more than the average culture, which sometimes you notice when you're traveling to another country, okay, particularly in a tight bus or in a train car. Okay, so bathing and also laundry is significant. Washing dishes is significant. Again, and then one of the essentials, basically, and what I mean by essentials, essential for survival, is cooking and drinking, is only 2%. In some countries, this makes up most of the pie. So when we think about our water usage, guys, and we think about how other countries behave, we're probably the most wasteful as far as the biggest part of our pie is stuff that could be easily reduced or even eliminated in many cases. We do it out of habit, and particularly we do it because we feel that water is cheap and free. And it's not till water becomes expensive or we discover that it's polluted, we find creative uses for it or ways of reducing it. Many countries use dirty water in their toilets and sometimes in their bathing, and particularly for any landscaping or agriculture and stuff like that. So again, when we look at domestic water, we can compare also the price of water. Price of water in the United States is incredibly cheap compared to other countries, and a lot of that is just based on our infrastructure, the way we tax things, and just the ease of getting water. When we look at certain countries like Germany or France, water's darn expensive. In my mom's country and in my dad's home country, you don't get ice. And you don't get water when you go to a restaurant. You don't even drink water during dinner. That was something we just didn't do because it was so expensive. And sometimes getting it clean was not easy. So people tend to use it very little. And it's not only because of the price. It's only because it's just something we get used to doing. Look at the United States and Canada. Spoiled, Canada gets a lot of water in the form of ice. You know, we get a lot of water in the form of rain, but they're a little less using than we are, but still, we keep the price down and we tend to use more as if it's a commodity that's not a problem to get a hold of. When we look at use of water globally, and this is not just domestic use now, this is looking at how we live our lives. So this is water as far as the whole society goes. That means water used for activities like agriculture and industry. And when we look at the world, and this is kind of probably rational when we look at this, agriculture is a major user of water, globally about 60%. Industry looks at a little less than 20% of that. And then we look at household use globally, it's very little. And this takes into account the fact that about 80% of the world is still in developing conditions. So they're primarily agricultural countries, very little domestic use. I remember when we took students to the Philippines and when I was in Colombia and rural parts of other countries, people sometimes have to share water. They don't use water in toilets. They bathe in gray water. They wash their clothes in water that was used for something else. When we look at North America in general, okay, it means United States and Canada. Okay, we see that the shift in agriculture is a little down and industrial water is bigger and residential water in particular, where more than twice of what the world uses. We look at Central America. Central America is very typical of rural agricultural countries. And then South America, which has its major cities, but still not up to what we see in the United States as far as industrial, but very heavy under residential. Africa, again, typical of developing countries. Oceania, that means like the Polynesian Islands, the whole scatters of thousands of islands, very heavy on domestic. And a lot is because of they're collecting a lot of fresh water. They have all they have is availability of salt water, but their domestic use is very high. And we can go on and on with this. But the point is we can compare countries and see by their level of development what their emphasis on water is. And particularly in the United States, we have a heavy industrial use. And the problem with industrial water is it uses not only a large volume, but it tends to produce a lot of pollution, which makes that water difficult to clean and reuse. And in many cases, it's disposed in one of many ways. So water pollution in general, you're going to see a video on this again. And they're going to divide the video is going to divide the water pollution into what we call point source. And that basically means I can point my finger to it, at it, or I can point an object that produces a particular pollution I found. Point source is very specific of factories and manufacturing. That means I can actually look for a pipe coming out of a company that produces a pollutant. And why do companies put pollutants into waterways? Is because under current guidelines, if you have a particular pollutant and it could be diluted, we put it in the water because the pollutant starts out at a very low level, and this means just how much oxygen is in water. That's an indicator of water quality. That means the abundance of oxygen in water and availability for life. And usually the more different types of pollutants in the water, the lower that number goes. So here we see the water is so polluted, it's literally almost a dead zone. No oxygen for plants or for fish to use. And then it gets diluted over time to the point where if you're down here, it's almost what it was over here, and there it's actually clean. Now, this is not always true, but in some cases it can. And pollutants that dissolve in water do this very easily. Pollutants that dissolve in oils tend to stick around in the soil and tend to get accumulated in wildlife and drags that high number all the way down here. So point source just means I can find where it's coming from. Non-point source means I can't point to an individual that is particularly producing that pollutant. So if you go into a heavily trafficked area, like let's say Manila, or you go into downtown Houston, there's a traffic jam, and you smell the polluted air, you can't point to one particular car and say, hey, that's where your pollution is coming from. That's non-point. Also, pollution in a sewer is non-point. That means we can't tell what particular house is producing that pollution, and it's all what we call aggregate. Non-point is easy to spot, it's easy to penalize, and it's easy to control. Non-point is almost impossible. How do you control every household is the question. And when we look at, again, where water pollution goes, water pollution can enter a man-made body of water, sometimes called a lagoon or a strip, and that can get into the soil. It can go down disposal wells, which again gets into soils and even sometimes aquifer and groundwater. It can go into rivers. So water pollution is not just a pollutant of bodies of water. It is also a pollutant of soil, and in many cases, if it's stored in ditches, in landfills, that could also become an air pollution quality issue as certain water pollutants evaporate. So this is water pollution. Again, you'll see more of this on a video. I'm just giving you some general principles here to understand the video. Now, when we look at how we treat water, there's what's called water catchment and water treatment. With water catchment, what we do is, this is how we collect water and clean it up. So when we start looking at water catchment and treatment, okay, water catchment means we collect water from either surface areas or buried water. This is groundwater, that's surface water. Usually surface water, which we don't have a lot down here. We're going to see more and more in our area in particular. This is water that's exposed to the environment. Of course, this will be polluted and silty and full of fish poop and other stuff. And what we tend to do is we chemically clean it up, or we gently settle out stuff. We don't sterilize it, guys. It comes out still the way it is. Many contaminants are in there. We sometimes filter it so you don't see chunks, and sometimes you'll smell your water's a little heavy on the chlorine. It smells like swimming pool, or it has an off taste. That's all due to the chemicals and the amount of contamination I got in here. That then could be, depending on your system, is disinfected, stored, which in a way cleans it. Sometimes it encourages bacterial and algal growth, and then that goes to your tap. That's one type of catchment with a treatment. This is catchment usually without treatment, and this is typical for here when we look at aquifers. And this is one particular type of aquifer where we tap into it. This is what City of Houston does, and parts of a lot of Harris County, and we literally take that water directly out of the ground. It's filtered and cleaned. Sometimes we add chemicals to it to treat it, just to make it more tasty, or in case we do find it there's a contaminant in it, we might want to get rid of it, but that's very rare. Is we take that water directly, and that's why it's great to take out of aquifers. We're going to be eventually converting over to surface water, and that's going to be an issue because that's going to make water more expensive, and we have to set up these elaborate treatment systems to clean it. Now, once water is used, we call this recharge. That means the water is out of your body, out of whatever it's doing, out of the factory, out of your tub, out of a pot of water you just put down the drain, and now it's going to wastewater treatment. Many countries don't have wastewater treatment. Literally, the raw waste and raw sewage goes into the ground or into a river. And I've seen this many, many times, and they can't afford to treat. These are very expensive facilities, and I'll post a video on that too for you to watch for your entertainment and learning, so you kind of know where your poo and your pee goes, or anything else you're throwing on the toilet. Water treatment is a very elaborate process that takes basically water from sewer pipes, from drains, street drains, whatever, even street runoff, and it screens it, removes large chunks. Some chunks the size of cars can get in there. Some of the worst things you can put in here in a sewage treatment plant are like too much paper. That means non-toilet paper, cloth, pieces of metal, dental floss, hate to say this, but tampons, sanitary napkins, because they all clog these screens and clog the system. Sand and grit, oil, that means any type of motor oil or even cooking fat, bacon fat, grease, can clog up the system, and it can even clog up the system downstream. So when we look at sewage treatment, so you have this first process called the primary process, which basically just settles out stuff. It settles out large chunks of poop, and it digests it. It means it breaks the poop down, very much like you see in septic systems in a house. It removes the grit, removes solids, and then we aerated it, which basically encourages the growth of beneficial bacteria that get rid of disease-causing agents and also break down a lot of the junk that you don't want to dump into the environment. The heavy stuff becomes sludge, and all of this we're going to see gets collected later. Then in many sewage treatment plants, we clear the water up. That means we settle out stuff and we disinfect it with either chlorine, that means what we use to sterilize swimming pools, very dangerous ultraviolet light, and sometimes toxic gases like ozone or ethylene chloride, which are toxic, but once they sterilize the water, it's okay. Most municipalities can't afford to do this very easily, and the water goes out either into rivers, into oceans, or into what are called recharge areas. It means back into the soil, okay, in somewhat of a clean way that we call potable. Most sewage treatment plants, you do not want to have what's called fourth level. This is first level, second level, third level, and fourth level is called quaternary treatment, because that means incredible disinfection, okay, to the point where the water you can literally drink as it comes out of the facility. So probably one of the most important aspects of water usage is cleaning it up. And guys, that's why when you take shower water, does not really have to be cleaned that much. And when you're just wasting water, period, letting it run, that's a problem, because you're taking clean water and now putting through a system that's very expensive to run and ramming that water right through here. And guys, this system too is also not foolproof. Creatures that cause disease can pass right through the systems. When you take drugs, pharmaceuticals, or illegal, whatever you do, that all comes out of here too the minute you pee or poop it out. Many things pass through here. Hazardous chemicals don't get removed by treatment. So remember, that eventually becomes your recharge water, which comes back into your house and then again is cycled through your everyday living. So let's go from water to atmosphere. Very quick transition here. I want you to know the parts of the atmosphere, because this is very critical when we try to understand, how our Earth works. So the lowest part of our atmosphere, and this is in meters, and this is in kilometers, period, I should say. So this is 10,000 kilometers, which means about 30,000 feet. Mount Everest is about 29,000 feet high. And a lot of your jumbo jets or jet aircraft fly about this level to avoid hitting mountains, and also because that part of the atmosphere is very cold, about -80 to -120, and that makes the planes more fuel efficient. And also there's less friction on the plane and better aerodynamics in a way on the plane. A lot of Air Force jets fly about here, but that's very difficult. There's almost no oxygen, whatever, and that's in the layer called the ozone layer. We'll talk about in a minute. So this is called the troposphere. The lowest level of the troposphere, that means right about here, literally halfway up that mountain and to whatever, and sometimes these peaks, we find something called the biosphere. That means a part of the atmosphere where organisms exist. Because guys, many organisms can't exist here. Humans can't without special assistance. You will either freeze to death or suffocate. So the troposphere is what contains heavy amounts of oxygen. And we're going to see that most of the atmosphere is actually made of what's called nitrogen gas, about 70%. A small percent of that is made up of atmospheric oxygen. Another percent, about 0.04%, is made up of carbon dioxide, which is essential for plants. It's deadly to us. And then we have other things making up this troposphere. So the troposphere is kind of like the livable part of the Earth. As you get towards the top, that's not so true. And a lot of it is because the additional sunlight that's up there, especially ultraviolet light, the lower amounts of oxygen in the atmosphere, and also the again the extreme cold that we find out there, and also pretty extreme winds. The stratosphere is a level above the troposphere, and it's loaded with a dangerous gas called ozone. Ozone is safe up here. It's deadly down here, and usually down here is the result of pollution, air pollution. Up here, ozone is naturally formed as a result of oxygen in the environment and also the intensity of sunlight. This ozone actually blocks particularly ultraviolet light, UV light, and other things. This is essential to protect the Earth. Down here, ozone is not. It's a pollutant, and we report ozone pollution days literally regularly in our area, because it could be that deadly and affect elderly people and children and people that are doing athletic activities. So the stratosphere, it's a commercial layer for us. We send a lot of jets up there, okay, but it could be a very cold area, and in some cases a very warm area, depending on where you are and depending on the amount of the radiation that's in that area. Okay, when we get to the mesosphere and thermosphere, these are non-livable areas for us, but they also play a critical role. Once we start getting around the thermosphere and towards outer space, because right up here, man, it is dark. I mean, it is dark. Okay, we start to get high levels of radiation, in some cases very extreme temperatures up here. Now, up here, we also find a nasty pollution called space dust. That means stuff that we've produced, microscopic dust, okay, that comes from burnt up rocket ships and satellites and stuff like that. And this dust can contain anywhere from heavy metals, other toxic materials, to radioactive materials, and other things that can come down towards the Earth. The space dust usually travels around above the atmosphere, or the troposphere, at about 24,000 miles an hour in particles sometimes the size of a bus, to sometimes mostly the size of microscopic pieces. But imagine that, traveling that fast. And a lot of it eventually comes down to the Earth, burns up, and becomes a pollutant in its own sense. So this is the atmosphere. Please know the parts and the approximate distances from the Earth. Now, within the atmosphere itself, too, we find these constant winds that are driven by ocean temperature and driven by the spinning of the Earth. So we find these winds that kind of take the atmosphere and move it around and shuffle it and shake it around and disperse it like this, and also disperse it in movements that cause ocean currents and create waves. So notice how these things move around, and what we'll see is these little swirls here, what are called cells, can actually take warm, moist air and make it cool and dry, and take that cool, dry air and deposit it in another area. So what we find here is somewhat cool, dry air, warm, moist air due to these cells. And this takes warm, moist air, it brings it along the ground, opposite direction, it spins, and then picks up moisture for the ocean again and deposits that here and makes this area wetter, and then this area be drier. So we see these sometimes bands, and this significantly affects biomes of cooler and warmer regions as we move from the equator towards the poles. These also create ocean currents, and also oceans can have an influence on their temperature, and these things can have an influence on the temperature of the ocean. So the atmosphere is pretty complex. And think about it too. If you produce a pollutant in your area, it can get caught up in these winds, in these cells, and end up being carried almost anywhere in the Earth, which we discovered is true for catastrophic pollution situations, particularly Chernobyl, which dumped tons and tons of radioactive materials in the air that spread globally over the years through that system. So when we look at air pollution, you'll see a short video on this. We're going to classify air pollution into what we call primary pollutants and secondary. Primary means these are directly produced by us, as they are. And guys, when we start looking at air pollution, most of it in our country comes from cars. Then public transportation, that means not only stuff that moves us around, but trains, planes, and trucks that move our stuff around. Cars are number one. Just remember that when we start complaining about air pollution. Industry is a pale number two for air pollution. And then comes other things like, houses. And houses and industry are actually almost neck and neck. Because when we look at mowing a lawn, other things, heating a house, air conditioning a house, those all contribute to primary air pollutants, particularly the production of electricity. Electricity is probably number one as being a factor for air pollution. Then cars, number two. So think about that. Think about your lifestyle and how it affects the primary air pollutants. We shouldn't be poking at industry so much as looking at ourselves, because we would have the biggest effect if we were to reduce the pollution from our houses. And it just means saving electricity and driving carefully and using cars that are more gas efficient, or just not using public transportation, not driving at all in some cases. So you're going to learn about a little later a pollutant called carbon monoxide. Don't compare that with carbon dioxide. Carbon dioxide is a natural it's a natural waste product, but when we from us and from animals and even plants, and it's a natural component of the universe and is found on almost every planet. The problem with carbon dioxide, when it gets abundant, it's a pollutant. Now, carbon monoxide, it does have natural sources, but it's mostly from human activities. We have things called volatile organic compounds. Most people in the trade don't call it that. We call them VOX. VOAC, and the S is supposed to be small. We call them VOX. These are things that come particularly from burning petroleum. They can also come from motors. They can come from photocopiers. They can come from a lot of stuff, and even your rear end at times, depending on what you eat. There's something called particulate matter. You mostly see this from diesel trucks and also from coal burning industries. These are particles. And you're going to learn in your video that these can accumulate in your lungs and cause major illness. These are also called SOx. And don't worry about what the X is. It means different forms. If you take chemistry, that's a lowercase x as a underscore or whatever. Okay, these are called SOx and these are called NOx. And you're going to learn about these also in a short video. You'll need to watch those for your test. So these are all contaminants that sometimes can be very deadly. They come again mostly from cars and from petroleum operations. And these are very deadly because they can mix with water and form acids. And we mean acids strong enough to dissolve chalk, to burn your eyes and do other things. And these are the pollutants that really harm you and you feel on your skin, in your eyes, and in your throat. They make you choke when you breathe it in. Then we have what are called secondary pollutants. And that means these form as a result of chemical reactions from other pollutants. And one of them is ozone. So guys, we have two ozone problems due to pollution. One in which our pollution is accumulating ozone in a troposphere where it doesn't belong. And guys, ozone acts like bleach. High enough ozone can kill anything and bleach the skin off your bones. It will bleach your lungs and cause lung damage. Upper atmospheric ozone is needed to protect us from excess sunlight, particularly UV radiation. If we didn't have an upper atmosphere ozone, we would be a totally different lifestyle. We wouldn't be alive, or we'd be something totally different. Upper atmosphere ozone, unfortunately, we're killing as a result of pollution, particularly what we call VOX and certain types of VOX that were found in propellants and air conditioning units. We've reduced that a lot, but still it's a problem, particularly in countries that have not upscaled the removal of the compounds that do that. So when we look at secondary pollutants, ozone is one, and also one which is actually a mixture of pollution we're going to cover in a minute, called smog, which basically means photochemical pollutant that's mixed with moisture, mixed with fog. That's where the og comes from. So here again, and guys, you'll sometimes see when we look at air quality, in the United States at least, we focus on certain types of pollutants. Before we didn't mention lead as a primary pollutant, and that also is an important one. So when we classify pollutants, we look at particular ones that we find the most important, the easiest ones to deal with, and the easiest ones to measure. Because guys, they could be about up to 2,000, 3,000 air pollutants. Some of them are minor, some of them, yes, like VOX are bad, but sometimes we have to ignore them for these because they cause the most damage not only to your body, but to waterways, to the environment. We got to think about that and whatever, because this and this can kill fish, frogs, everything almost immediately, depending on how high the contaminants are. A big problem that we had in the United States at one time, it has been reduced, but it doesn't mean it's been eliminated. I've seen this in many countries, particularly London, to the point where we've had people dying from it. And guys, people do die from this, what's called photochemical smog. And usually this is all caps. I'm used to seeing it all caps. So primary cause is automobiles. Sunlight does produce it too. It's the reactor, but guys, what we're going to do, block the sun. I mean, golly. Okay, so automobiles are the major contributors to this. Industries number two. Housing, kind of small. But this is particularly when we get volatile organic compounds that particularly come from burning petroleum. This is why burning petroleum is a damn bad thing to do. It also can come from biofuels. So don't think with biofuels you're reducing this. Okay, biodiesel, whatever. Biodiesel produces these and particulates, so it's actually worse when we start looking at going diesel. So the more your gas mileage is, the more you produce this. And what happens, these chemicals get together, they mix with sunlight, they mix with stagnant air particularly, and they form something called smog, which can kill people. In 3 days, a London smog, because London usually gets fogs. Unfortunately, you also got this plume of pollution and stagnant air for 3 days that killed about 17,000 people that they know of. Literally just dropped dead in 3 days. Some of them, a lot of them elderly, some of them babies, but a lot of them just your age range, which is kind of horrible. And I can show you a video on that. If you want, I can give you a link. Guys, probably one of the biggest issues we have that have to do with air quality is indoors. And this is, we don't think about it. We living indoors, we are killing ourselves. We learn that people that live in, primitive style housing where it's open to the environment, assuming that their outdoor air quality is clean, their house is clean. Guys, you live in an area where the outdoor air quality is bad and your indoor air quality is worse. This is produced primarily from having indoor toilets. Okay, where do I put my toilet? Outside, probably. That would be kind of cool as long as you heat it or cool it. Why not? Keeps it away from fuming up the house. And particularly depending on what you eat, that could be pretty polluting in the air. So this comes from a lot from cooking inside, from electronic devices in particular, and electricity in general. So guys, right now I'm sitting in front of my computer. That's producing fumes that are killing me. So teaching is killing me, particularly online. But being in a classroom is no better because the overhead projector, the computer that's on in there, and all the electrical lighting is killing us too. So guys, this is an issue, and the public tends to not be aware of it or downplay it. You can go onto the EPA website and search this and find out that this is an issue that we can deal with, but it's very expensive to fix. And guys, some of these chemicals, a lot of them are cancer-causing agents. And the Department of Energy already has an incredible study that shows people that live in houses like ours, particularly those made up of wallboard and cement, which contains an indoor pollutant called radon. It's a radioactive gas. It's killing us. It's increasing our DNA damage, and it's actually increasing our susceptibility to disease. Yes, we live in a society that lives longer, and we can sometimes counteract the effect of this. But when you start talking about people that are poor and can't eat healthy and can't get medical care, they're the ones that suffer from indoor air quality, and school children particularly. So guys, again, you're going to be looking at air pollutants in another video. Last but not least, we're going to look at the whole idea of solid waste. And solid waste is difficult to explain. Basically, it's anything that mostly ends up on land, but as you can see here, ends up in water. And guys, this is not an exception to the rule. When people don't have bathing water, they can't pump it out of a tap. This is bathing water. And I've seen kids playing in this. I've seen people recycling stuff out of here. This is not unusual. I have pictures I've taken where the water was solid waste. That's kind of redundant, but whatever. This ends up on the ground, and sometimes this volatilizes and ends up as air pollution. So when we look at solid waste, usually it's classified by who produces it. So we have household waste, we have commercial waste, that means small commercial waste, that means from local stores, barbershops, you name it, dry cleaners, whatever. We have large manufacturing waste, we have mining waste, agricultural waste. All of them come from different sources, and we can categorize waste according to whether we have to dispose of them, they're non-recyclable or non-renewable, and some that are renewable. And we also have a solid waste called hazardous. We're going to cover that a little later. Not all of our waste is recyclable. Some of it cannot be, and some of it, and most of that is due to the chemical nature of the material. Some of it you just can't do anything with. It's such an exotic compound. Some of it is because we don't have the technology to do it yet, and some of it because it's not economically feasible. Our campus recycles, but the problem is we have to pay for it because there's very little economy in recycling. Guys, electronic waste is probably the biggest recycling problem ever. It's expensive and dangerous to recycle. There's many toxic substances, not just the battery, but the circuitry itself, many of the materials. And what we do is we ship that overseas where it's cheaper to recycle, and people don't have the environmental regulations. So what happens is some of our solid waste gets shipped overseas where people suffer from it. and they get paid very little. Yes, it's an economy for them, but it also shortens their life. And I know that from being there and seeing that, particularly in children, young kids, 5 years old and up, are doing that for a living to make their $1 a day to $5 a day. $5 a day, woo, that's a lot in some areas. But what happens is that material then gets shipped back to us. Mostly what we find about recycling solid waste is it's more of an economic thing, and also what it does is it doesn't reduce pollution as much as it reduces having to mine stuff. Particularly recycling paper uses less trees. But guys, understand recycling produces pollution. Uses a lot of water, it produces a lot of air pollution, uses a lot of electricity. Just remember that. There's a cost benefit to it. And guys, I know particularly with water pollution, our area suffers from the outflow of water pollution from Angelina County that has a large paper recycling facility that takes the paper and actually turns it into other materials. So remember that. So all of this is a cost benefit. So solid waste has been a problem for humans for years. And typically what we've done is we've dumped the waste in waterways or on ground. Farmers still do this. They dump it in ditches. University I was at in Oklahoma, whenever we found a giant ditch, we would dump stuff in, bury it up, and put houses or schools on top of it. They also, not Oklahoma, my university, but some areas at one time put hazardous waste in those ditches many years ago. Today we don't do that. So solid waste is always an issue, and it's a primary issue, particularly of our area, because we're running out of places to put it. And as people come here and move here and our population goes up, more and more occurs. So you're going to hear a little more about solid waste in another video, a short video, and you're going to learn about mining waste. These tend to be very local and exotic, but guys, we need this. This is our resources, and mining waste could also come from oil, petrol, and coal. So we produce this waste called tailings, which comes from not just mining, but the manufacturing process too, and cleaning process. We have agricultural waste, and some of this comes from you, how you want your food. Okay, we waste a lot of our foods. We eat an average of 30% of the food that is put in front of us, we throw away to waste. It doesn't get recycled. It goes into toilets, or it goes into sewer systems, or it goes into landfills. I mulch mine. I keep it in the system. It goes back to the soil, but definitely not where it was coming from. So agricultural waste is a big one, and we don't have to have it. Earlier societies didn't. We're just in a situation where we do this incredibly expensive agriculture where it's sometimes not feasible to not produce waste and to reduce waste or just find something else to do with the waste. Okay, so this is a big issue. You'll hear about it a little later, but it's something that's very difficult for us to control. And then we have the industrial manufacturing waste. And believe it or not, and guys, look at that number. This is an approximate number, but guys, this number now is lowering as regulations go up, and this number is going down. So that means we eventually might exceed. That means municipal, meaning households, what cities produce from small shops, operations. It means car repair, you name it, grocery stores, okay, movie theaters. That's all municipal. That means city living, even rural living in a small town. We're going to exceed eventually industrial because they have more of an incentive to recycle, reuse, and not have as much. Guys, Amazon, I'm not putting them down, but the fact that we sit on our butt and order stuff has increased the amount of packaging so much that it's creating a problem. That's municipal. And that's a problem. It's literally in some areas doubled the amount of waste through the packaging, the boxes, and the amount of boxes in general, just the amount of material that comes. And because we want to ship stuff without breaking, sometimes you have to put it in large boxes with large packing material. So these are, again, the major categories of waste. And guys, within these categories, we can identify it based on its disposability or whether it's hazardous or not. And we're going to cover hazardous a little later. Guys, when we look at the United States, because each country varies, and in some places you hardly find any waste. And you know what's funny, guys? Our holidays, like this poor turkey here, will succumb to if you do turkey on your holidays, okay, or even pig if you eat that on your holidays in a form of, ham, whatever, okay, is that those are very wasteful things. Big meals, parties isn't that horrible. The way we maintain our house, our general lifestyles of how we shop, how we just live in general, how we want conveniences, makes us a very wasteful society. And again, it's just the way we grew. It's the what you're accustomed to. It's not necessarily bad if we don't do something to make it sustainable. So you can live a pretty reasonable lifestyle as long as those materials don't end up as waste. And there's a clean way to reuse it, recycle. And that sometimes means affecting our quality or making life a little more inconvenient. So we find food scraps, whoops, is a biggie. And many schools are looking at individually reducing this. I know in France there's a big movement to reduce food scraps. Many farmers in developing countries use the food scraps as animal feed. There's no waste in that, particularly fish feed. It's very good for, or for their pets. I mean, my dogs got rid of food scraps, which probably didn't, help them live any longer than they did. Whatever. But we see yard trimmings is very, very bad. This is why I'm against yards. I protest having to have a yard. I'd rather have a pile of decorative rock, but we're not allowed to do that, except without special permission. And we've gotten turned down a couple of times due to it, to petition for it. We see wood. A lot of waste wood gets thrown out, rubber, leather, textiles, stuff that's very difficult to recycle in our country. Other countries do. Plastics are on the rise. This number is growing. Metals are on the rise. We still throw out a lot. Glass is very difficult, expensive to recycle, so you see a lot of this ending up in waste. And look at the paper and cardboard. It's a little different than wood. This is processed wood, which means a lot of pollution went into making this. And that means every time we demand more, it takes more manufacturing to do that. And then other just includes wear junk. I don't even want to go into that. Okay, so whatever. So this is us. And notice some of these things are not essential. Food scraps are not essential. I'm serious. They can go somewhere else instead of having to be disposed of. They could be reused. Yard trimmings could be removed. I know many cities in Texas recycle yard trimmings. They actually mix it with food scraps and turn it into animal feed if it's clean, if it meets USDA, approval for animal feed, or it can be used as plant fertilizer. It can be sprayed onto farms. They actually turn it into a mulch and spray into farms. There was a machine in China I once got to see operate. It's a giant machine, requires very little human labor, and it takes all this junk, separates it. That means even food scraps, and can separate it all in this one conveyor belt machine, and have all these things cleaned and ready to be recycled or reused. I know in our country we have what is called single stream recycling units that somewhat do that, but not to the efficiency, and we usually are very selective. Like, we don't want a lot of glass sometimes, most of the times we don't want food scraps. Certain things, a lot of places don't take rubber, leather, and textiles either. That all gets disposed. Some countries that gets recycled, yes, even back into clothing and materials for living. So guys, it makes sense. As human population goes up, obviously our total waste goes up. Okay, and this is just data, so you can see that throughout the years, okay, our kilograms per person a day is also growing up, and this is what kind of bugs me. So that means us as a user from 1960 to 2015, and this is kind of stabilized a little, but as population, so guys, our uses per person is kind of stabilized, but this graph the graph overall is going up because of the increasing amount of people. Now, United States is stabilizing. Countries that are growing, obviously, this is going up. But we use a hell of a lot, guys. Look at that. Kilograms per person of waste. Okay, per day. So that means in our room, in us, in our country, per person, okay, you're producing, 3 pounds of waste a day. That means solid waste that's not disposed. It's about 1 kilogram. Okay, a little more than 1 kilogram, and that's ridiculous that we do that. And this is all stuff that can probably be used for something else. Okay, and 3 pounds a day, guys, doesn't sound like much per person, but think about a household, and think about what would happen if you don't throw that stuff out for 3 weeks. How that builds up. We did it in my house just for fun once. Actually, it was a class experiment, and the students could not believe how much junk accumulated and how it began to stink too. And now we also look at, guys, here on this graph, we can compare the amount of waste after recycling to the amount of total waste. And guys, this was going smoothly. And then it hit a point where recycling became economically not feasible. And the recycling is tapered off. And I hate to say it, guys, as recycling companies are becoming less profitable, this is starting to shrink a little. Actually, we are worse than developing countries, where out of desperation, most people recycle. And it's also true of Canada and Europe, certain developed countries. So we don't have a good example to set here when we start talking about environmental stewardship. Waste generation per lifestyle. Look at again the United States, kilograms per day, and I know you're going to see this a little different. It depends on what you're measuring. This is now not just including household waste. This is including waste per whatever. So this is household waste, and that means there are other waste that you use when you're living that you don't see, what's called the hidden cost, the hidden waste, or the external factor. External factor meaning what you don't see. That's not directly part of the usage of the material, but indirectly associated with making it and shipping it and whatever. Canadians a little better than us. Europe in general, Japan, they have to. They're desperate for resources. And then, of course, we start developing, going into semi-developed and developing countries, particularly India. There's very little waste to produce because there's very few things that people have. And they've learned to recycle, reuse. And that's what I find beautiful about that. So guys, when we start talking about disposal, guys, that's what do we do with our waste? How do we dispose of it? Okay, what we can look at here, guys, is most stuff goes into landfill. There's many types of landfills. So we can put it in a ditch, we can put it in a mound and create this mountain of trash. There's all sorts of ways we do this, but landfill is still the primary across the world. It's the most ancient technology. Ancient people did this. Matter of fact, ancient Samoans, Polynesians had a problem with this on their islands, and a lot of it had to be ended up dumped into the ocean. Okay, so landfills, direct disposal. Recycle is still pretty significant, but not enough to the point where we can have zero going into landfills. Canada is starting to shut down all their landfills and going 100% what we call recycling or recovering for recycle. We could also compost. That means turning stuff into this mushy, slushy stuff that we could use for soil recovery and for agriculture and golf courses and things like that. And then, guys, we could burn waste. Europe is looking at these incredible structures for taking waste and burning it at very high levels to generate material that can generate more energy and also extract every material, particularly hazardous waste. So we have the technology that we can take any waste, even those that we can't normally dispose of, and put it into a device that we know now in Italy, England, Germany, I think, and I forgot where the other units are sold. They're trying them out in China. Other countries are cost effective. The United States is not even looking at this technology. We're ignoring it beyond belief. And yet it's making profits in countries that have worse economies than us and a closer margin of profit. So we don't have to have this picture. We can have that picture either totally this and this. And even for composting a little. So we can turn this into this very easily. Okay, so when we look at, again, combustion, this is neat. Energy from trash. Key West does this. I think we were trying to look at one of these in Houston and it was turned down. Not by political officials, by people. They didn't want the burning stuff. And guys, if you go to like Key West, you go to areas that have these what are called incinerators, electrical generator incinerators. They can burn tires in them. You see no soot. I see more soot coming out of a car than I do out of these facilities. It's amazing what we have available to us, and we don't exploit it yet. And a lot of it is not so much cost efficiency as much as just habit. So here's a landfill. This is very typical. It's not just a hole in the ground. They're very complex, especially today. They have a barrier on the bottom to prevent rainwater and liquids and other junk from leaking into the soil, particularly if there's water underneath it. We usually have little sampling stations that make sure the soil and the water is not being contaminated by here. This is how, with the Keystone leak that just occurred, guys, that stuff is getting in the soil. And they're going to now have to drill these type of holes to look to see if the water is contaminated or not. In all these areas, very expensive. Landfills normally have these. That's why when you build a landfill, guys, this is not a very profitable business because they spend a lot to set these things up, and then they basically have to charge someone almost a lifetime in a landfill to keep the stuff there. Hazardous waste landfills, you pay a lifetime fee. You pay a pretty steep fee for getting rid of trash because that's considering the fact that these things have to run sometimes for a very long time until they're out of commission and a person can sell the land for something else. They have people working here monitoring water, and also if it collects the gas that comes out of these, monitoring the gas. So these throw your junk in here, it produces liquid waste that we try to capture and clean and recycle through here. This produces gases, particularly something called methane, which either can be released or burned. You see this in the Humble one. They burn this. Okay, and you can see little flames coming out. This is not a wildfire. This is actually a flame that they burn off the gas to keep it from getting into the atmosphere. Or you can put it into a pipe and collect it. And we did it, our students did a project in this in the Philippines, where we collected refuse waste and sewage waste and turned it into methane gas that people could use for cooking or for other purposes, or sell the methane gas to other people. And this is called the leachate, guys. This is where all the contaminated water from here has to be disposed of. So, guys, the average refuse, the rubbish, the waste, guys, it can take hundreds to thousands of years to break down. If you were to dig deep into this landfill, and University of Arizona, I believe it is, has a garbology lab. This is all they study. There are other universities too. I think they were the first. And they actually dig deep down into these garbage dumps. And guys, they find still intact, like Kentucky Fried chicken wings. They find wrappers intact. They find newspapers still readable. Once stuff gets in here, guys, it doesn't decay that much. It really doesn't. When people dump bodies in these things, they're still intact. There's still enough tissue on them to even make recognition and sometimes collect DNA. These are very almost sterile environments. You don't want too much bacterial action because it can produce heat and a lot of gas and cause this thing to blow up. This has happened before. One happened actually in the Copperfield area where they weren't monitoring it that well, I guess. So on that note, please watch the videos I give you and answer, the habitable planet that has to do with atmosphere and atmospheric pollutant, because that is a big one in our area. I mean, water pollution is also big, but air quality is a major one that you actually feel the impacts on. So again, any questions, leave me a voicemail. Well, actually, we're used to now. Just leave me an email, okay, and ask me. On that note, goodbye and thank you.